Hello everyone. In this section, we will introduce TensorFlow. There are specific libraries available to develop deep learning applications such as Keras, TensorFlow, PyTorch, Caffe, and Tino. Now let's discuss why we use TensorFlow. One of TensorFlow's best qualities is that it makes code development easy. The readily available APIs save users from rewriting some of the code that would otherwise have been time-consuming. TensorFlow speeds up the process of training a model. Additionally, the chances of errors in the program are also reduced, typically by 55 to 85%. The other important aspect is TensorFlow is highly scalable. You can write your code and then make it run either on CPU, GPU, or across a cluster of these systems for the training purpose. Generally, training the model is where a large part of the computation goes. Also, the process of training is repeated multiple times to solve any issues that may arise. This process leads to the consumption of more power, and therefore, you need a distributed computing. If you need to process large amounts of data, TensorFlow makes it easy by running the code in a distributed manner. GPUs, or graphical processing units, have become very popular. NVIDIA is one of the leaders in this space. It is good at performing mathematical computations, such as metric multiplication, and plays a significant role in deep learning. TensorFlow also has integration with C++ and the Python API, making development much faster. TensorFlow can be defined as follows: a popular machine learning library, particularly well suited for large-scale machine learning. A product by Google Brain team that is used in Google Photos, Google Search, and Google Cloud Speech. An open-source software library for numerical computation using data flow or computational graphs. A distributed computing tool that enables clusters neural networks to be trained across distributed servers. Google has also launched a cloud service to run TensorFlow graphs. What does the tensor mean in the term TensorFlow? A tensor is a mathematical object represented as arrays of higher dimensions. These arrays of data with different sizes and ranks get fed as input to the neural network. These are the tensors. You can have arrays of vectors which are one-dimensional or matrices which are two-dimensional, but the tensors can be more than 3, 4, or 5-dimensional. Therefore, it helps in keeping the data very tight in one place and then performing all the analysis around that. This is an example of tensor of 4 dimensions, which is 2-dimensional. And this is an example of a tensor of dimension 3, 3, 3, which is 3-dimensional. Tensor rank is nothing but the dimension of the tensor. It starts with 0. 0 is a scalar that doesn't have multiple entries in it. It's a single value. For example, s equals 1 is a tensor of rank 0 or a scalar. V equals 1, 2, 3 is a tensor of rank 1 or a vector. M equals 1, 2, 3, and 4, 5, 6 is a tensor of rank 2 or a matrix. Everything in TensorFlow is based on designing a computational graph. So what is a computational graph? Well, a computational graph is a series of TensorFlow operations arranged as nodes in the graph. Each node takes 0 or more tensors as input and produces a tensor as output. Let's look at an example of a simple computational graph which consists of 3 nodes, A, B, and C as shown here. Constant nodes are used to store constant values as it takes 0 input but produces the stored values as output. In this example, A and B are constant nodes with values 5 and 6 respectively. The node C represents the operation of multiplying constant node A with B. Therefore, executing node C will result in multiplication of constant node A and B. Basically, we can think of a computational graph as an alternative way of conceptualizing mathematical calculations that takes place in a TensorFlow program. The operations assigned to different nodes of a computational graph can be performed in parallel, thus providing a better performance in terms of computations. Here we just describe the computation. It doesn't compute anything. It does not hold any values. It just defines the operations specified in your code. In TensorFlow, assigning these variables is also an operation. Step 1 is to build the graph by assigning the variables. Step 2 of building the graph is to multiply B and C. Finally, we get the result. Here we have 3 nodes. First, we define each node and then create a session to execute the node. This step, in turn, will go back and execute each of the 3 nodes to get those values. Unlike other programming languages, TensorFlow allows us to assign data to 3 different data elements. Constant. We cannot change the values of constants during computation. Specifying the data, the constant is optional. Placeholder. A TensorFlow constant allows you to store a value, but what if you want your nodes to take inputs on the run? For this kind of functionality, placeholders are used, which allows your graph to take external inputs as parameters. Basically, a placeholder is a promise to provide a value later or during runtime. Variable. Variables allow us to add new trainable parameters to the graph. To define a variable, we use the tf.variable command and initialize them before running the graph in a session. This is the end of this section. Thanks for watching and welcome to the next period.